This video will certify you to use the AQUALAB3 water activity meter. Select a clean, level place that has relatively stable temperature. Small temperature changes won't affect your AQUALAB3's performance, but it shouldn't be located near heating or air conditioning vents or other sources of temperature fluctuation. The AQUALAB3 uses a chilled mirror method to measure water activity. To understand how it works, let's look at the inside of the sample chamber. When a sample is put into the chamber and the block is sealed, it comes to vapor equilibrium. Water molecules enter the air above the sample, and then the mirror is chilled until dew forms. The chilled mirror method is a primary measurement method, and it's the fastest, most accurate way to measure water activity. There are a few ingredients, including alcohols, petroleum products, organic solvents, spicy mixtures, propylene glycol, and soy sauce that can cause issues with the mirror when they're present in higher concentrations. The problem with these volatile ingredients is that they also float into the air and condense on the mirror, interfering with the readings. If you read samples that contain volatiles, check with the meter food support team to see if they will cause problems with the AQUALAB3 sensor. Before we actually take some sample measurements, we'd like to talk about sample preparation. When we tested how sample prep affects water activity readings, we found 5 things that will improve the accuracy of your readings. 1. Use clean sampling practices. Place your instrument in a clean location. Make sure you have clean hands or wear lab gloves. Use a clean sample cup for each reading. Fill your sample cup no more than half full. Wipe the bottom, the edges, and the rim of your sample cup with a Kim wipe before putting it in the instrument so you don't contaminate the sample chamber. Even small amounts of water or contamination can significantly affect the reading. 2. Protect your sample. The water activity of your sample changes as it's exposed to ambient conditions, so keep it covered. Put a lid on the sample if it will sit out for longer than a minute. If it will be waiting longer than a half an hour, seal the lid with parafilm. 3. Your sample temperature and block temperature need to be in the same general range before your reading can be taken. If it's too hot, water can condense on the inside of the sensor chamber. This ruins your water activity readings. If your sample is too hot or too cold, the instrument will ask you to take the sample out. If the temperature is only off by a few degrees, the instrument will wait as the sample comes to temperature. One way to reduce read times is by bringing the sample to temperature before putting it in the instrument. If the temperature differences are slowing down your read process, consider purchasing a temperature equilibration tray, which brings samples to a set temperature before you read them. 4. Take a representative sample. Whatever you put in the cup should be as close as possible to what the consumer takes out of the package. If the product won't fit, break it to fit, while minimizing handling. If it's a multi-component product like filled cake, cheese and crackers, or cereal with fruit, get a representative sample. By representative, we mean that all the components of the product should be represented in the same ratio as they are in the actual product. There are a couple of products that need special handling. Products with a moisture barrier, like coated candies, may be slow to come to equilibrium. They can be cut or crushed to expose the interior. Don't grind them, though. This causes moisture loss. In high-fat products, like fatty meat and desserts, the oil and fats become a moisture barrier. These products are slow to emit moisture. The sensors will work equally fast on these products, but the products themselves simply need a longer time to come to equilibration. A quick testing method will give you an inaccurate result. If you're testing these kinds of products, you may want to talk to someone on our support team about how to get the fastest, most accurate test results. 5. Minimize handling. In sample preparation, less is more. We've seen customers use all kinds of sample prep methods over the years, including grinders, food processors, and blenders. There are 2 problems here. First, the friction of the grinding process heats the sample, driving off moisture and changing its water activity. Second, the increased surface area means that the product loses or gains moisture more quickly, making it more susceptible to the effects of room humidity. Establish a standard operating procedure to specify how samples are prepared and be consistent. Your procedure should include how the sample is handled while waiting to be read and the temperature the sample and instrument should be at during the reading. When you set up this protocol, consider running your own tests to find which preparation method produces the most stable result. If the sample chamber or sensors become contaminated, your instrument will not measure water activity correctly. The best way to check for contamination inside your instrument is by running verification standards at the beginning of every shift. AQUALAB3 verification results are recorded in SKALA and attached to all readings taken during the shift, to prove to auditors and inspectors that readings were taken on a properly verified instrument. If you try to take a reading on an instrument with an expired verification, SKALA will remind you that verification is needed. Note that the timing of verification requirements can be changed in SKALA control to match your standard operating procedures. The best way to verify your instrument is to use a technique we call bracketing. If you are measuring a cookie that typically has a water activity of 0.6, you should use the 0.5 and 0.76 standards to verify. If you're measuring milk powder in the 0.3 range, you should use the 0.25 and 0.5 standards to verify. To perform an instrument verification, wash your hands or put on lab gloves. Select the standard you will read first. These verification standards are salt solutions with a known water activity value. They are tested with a densiometer to validate their accuracy. Standards are good for 1 year. Cover the bottom of a sample cup with standard solution. Place the cup in the sample drawer, close the drawer, and turn the read knob counterclockwise to start the reading. The slow pulse light indicates that the reading is in progress. When the reading is finished, you can instantly see if it is in or out of spec. If the reading is out of spec, SKALA will prompt you to clean the instrument. If it is in spec, you can move on to the second standard and complete the verification. Contaminants inside the AQUALAB3 sample chamber cause inaccurate readings and long read times. Contamination may or may not be visible. The best way to check for contamination is by verifying your instrument with standards at the start of each shift. If your verification standards read out of spec, the issue is almost always chamber contamination. Follow these cleaning steps and retest the instrument to resolve the problem. A cleaning kit is included with your instrument. You will get a new kit every year with your block swap. If you run out of cleaning supplies before then, you can order a replacement kit at sales.food@metergroup.com or by calling 509-332-5601. There are 3 steps to cleaning the sample chamber surface area and sensors. 1. Wash with isopropyl alcohol or cleaning solution. 2. Rinse with distilled water. 3. Dry with a clean Kim wipe. To start, unplug the AQUALAB3 power and USB cords. Wash your hands thoroughly or wear lab gloves so dirt and natural oils on your hands don't contaminate the cleaning materials or the sensors. Spread a clean Kim wipe on the lab bench. The sample cover is designed to protect the inside of the sample chamber from contamination and should be cleaned frequently. This may be enough to keep your instrument in spec and reduce the frequency of full instrument cleanings. Start the cleaning process by moistening a large Kim wipe with isopropyl alcohol or cleaning solution, and then wiping down the surface areas of the sample cover, especially where it comes in contact with the top of the sample cup. Because of regulations, we don't ship isopropyl alcohol in the cleaning kits, but it is often the best cleaning agent, particularly if you're measuring samples with a high fat content. You can use any concentration of isopropyl alcohol greater than 90%. Change Kim wipes frequently, even if they appear clean. If the Kim wipe appears dirty after cleaning, get a new Kim wipe and repeat the cleaning process. Now rinse the surface area just washed. Get a new large Kim wipe and moisten it with clean distilled water and rinse thoroughly. Be careful not to dip a used Kim wipe into the cleaning solution, isopropyl alcohol, or distilled water to avoid cross-contamination. Dry the sample cover with a new dry Kim wipe. Lay the sample cover aside on a clean Kim wipe. Open the drawer of the AQUALAB3 and remove the middle disc in the bottom of the sample drawer by rotating the disc. Clean the disc by first washing with cleaning solution or isopropyl alcohol, then rinsing with distilled water, then drying. Use a clean Kim wipe for each step of this procedure. Rinse the surface area of the drawer sample chamber with clean distilled water. Remember not to dip a dirty Kim wipe into your clean distilled water. As you clean, be sure to get into the corners by using a cleaning rod, strips of Kim wipes, and isopropyl alcohol or cleaning solution. Cover the end of a cleaning stick completely with a Kim wipe. To do this, tear the strip in half. If you use a whole strip, it'll be too thick to fit into all the corners of the sample chamber. Hold the stick at a 45-degree angle. Fold the corner over the stick and twist several turns. Once the end of the stick is covered, fold the strip back toward you and twist the end around the stick. It's important not to use a commercial swab, because the adhesives used to glue the cotton to the stick will contaminate the mirror and sensors. Kim wipes won't scratch the mirror and are adhesive-free and low lint. Wash and rinse the nooks and crannies of the drawer using the Kim wipe and the cleaning stick. Replace the disc and the sample cover and leave the drawer open to dry. Now remove the lid of the AQUALAB3 to expose the testing block. All moving parts and sensors are located inside this block, and it has been designed to allow you to access and clean the sample chamber and the sensors. Unplug the cable by pulling out on the tabs. Loosen the thumb screws and remove the block. Clean the face of the block with a Kim wipe using the same wash, rinse, dry procedure. Then clean the sensors and the testing block using a cleaning rod and Kim wipe strips. Use the same method to wrap half of a Kim wipe strip onto the cleaning rod. Following the same wash, rinse, dry process used to clean the sample cover and drawer, wash, rinse, and dry around the sensors in the upper block. Be careful when cleaning the sensors and the area around the fan, and be sure to get into all the corners. There are two sensors to be cleaned, the mirror and the infrared sensor. Clean each sensor separately by wiping across the sensor. Clean first with a clean Kim wipe and isopropyl alcohol or cleaning solution, then rinse with a fresh Kim wipe and distilled water, and finally dry with a clean, dry Kim wipe. To review, cleaning your instrument requires a 3-step procedure of washing, rinsing, and drying. You should use these 3 steps to clean 3 different parts of the instrument: the sample cover, the sample chamber inside the drawer, and the sample chamber inside the block. This procedure will help keep your instrument in spec, and note that careful sampling and measuring procedures can prevent contamination in the first place. Once the cleaning process is complete, let the sample chamber dry for about 5 minutes while you prepare your water activity standards for verification. Once the chamber is dry, replace the sensor block. Plug in the ribbon cable and make sure it is fully seated. Tighten the thumb screws. Replace the cover. Plug in the power and USB cables and turn the instrument on. SKALA will guide you in repeating the verification process. When your instrument reads in spec, you have finished cleaning your instrument. SKALA guides you through the process of taking a reading. Here are a few things to keep in mind while taking a reading. Always wash your hands or put on lab gloves. Prepare the sample according to the techniques discussed in the sample prep segment of the certification video. To avoid contaminating your instrument, fill the sample cup no more than half full, and clean the bottom, edges, and rim of the sample cup carefully with Kim wipes before setting the sample cup in the sample chamber. Log into SKALA using your passcode or RFID. Select the batch or lot or type it in. Choose Water Activity. The blue light will indicate which AQUALAB3 is ready for the test. Place the sample in the drawer. Slide in the drawer. The sample cover will automatically protect the edges of the sample cup. Note that the sample cover is designed to keep the inside of the sample chamber clean. The sample cover is easy to remove. You should inspect and clean it frequently using the wash, rinse, dry procedure described in the cleaning section of this training. When the reading is finished, the AQUALAB3 will indicate whether the reading is in spec, within CCP limits but out of operating limits, or outside CCP limits. The results will automatically be recorded in SKALA and cannot be erased.